In this class, we will discuss another problem, question paper problem of non-concurrent force system. So this has appeared in VTU January 2020 paper. The question given is like this: we have a trapezium here, trapezium like this. On this trapezium, forces are acting. So this is 3.5 meters and this is 4 meters and this is 6 meters. Like this. This is not known. So he has given some forces. One force is acting on this diagonal like this, 60 Newton force. Another force is acting on this edge, 50 Newton. Another force is acting at the midpoint of this, at right angles to this edge here. This is 20 Newton. So this I will take it as A, B, C, D, E. So this is A, B, C, D, and this is E. And he has given a 30 Newton force downwards at C and a clockwise moment of 100 Newton meter at B here, 100 Newton meter. So you have finally 30 Newton force here, downward force, 20 Newton force, right angles to this is 90 degrees. Then 100 Newton meter clockwise couple at B, 60 Newton along the diagonal, 50 Newton along this. So 1, 2, 3, 4, 5. So there are 4 forces and 1 moment. So this is the problem. So determine the resultant. Of course, he has not given any with respect to what point. So I will take with respect to point A. So we have to find out the locate resultant with respect to point A. So as usual, we need to find all the 3: magnitude, direction, position. So they ask x intercept and y intercept. That also we have to find out. Of course, here he has not asked that. We will find out D, then we will find out x and y. So here now, as usual, we have to resolve the forces along the two global x and y axis. So I will take global x direction like this, y direction like this. Let us resolve all the given forces into the components along x and y directions. So for that, I need to find this angle. Since this 60 Newton force is making an angle here, that angle is not known, but I can always find out that angle if I take that as theta 1. Tan theta 1 will be opposite side by there is adjacent side to this right angle triangle ADB. So it is tan theta 1 is 4 divided by 3.5, or you can take theta 1 as tan inverse of 4 divided by 3.5. So it will be, I will take tan inverse of 4 divided by 3.5, which is equal to 48.8 degrees. So theta 1 is 48.8 degrees. Let us have that. Then one more angle I need, this one. This of course he has given, that is the E is the midpoint. So I will take the E is the midpoint of BC. He has given that. So but I don't know the length of BC. So let us calculate that length. Then we need to get the value of this angle. So here, very important, we have to see the geometry. I will draw an ordinate here. So this becomes right angle triangle now. So this is from here to here is 3.5 meter. So therefore from here to here it will be 2.5. 6 minus 3.5 into 2.5. Now I will take this triangle. So let me take this as F1. Now I will take this triangle CFB. In triangle CFB, I need this angle. I will take this angle as theta 2. So I need to find that. So this is 2.5 meter and this is 4 meter. That is given. So FP is 4 meter, FC is 2.5. So I will take cos theta to ratio, or sorry, tan theta to ratio. tan theta 2 will be 4 divided by 2.5. So from the geometry, so therefore theta 2 will be, I will calculate tan inverse of 4 divided by 2.5, which is 57.9 or 58 degrees. So you can take theta 2 as 58 degrees. Now these two angles are known now. So once these two angles are known, so this is 58 degrees, once this is 58 degrees, so this will be 58 degrees. So this is 58 degrees, this will be 90 minus 58, 32 degrees. So once you know that, now you can easily find out the components of these two, so that we will resolve later. Now then I need this length also, BC length I need. For getting that BC length, what I will do here is, I will take this triangle, for triangle CFB, once again triangle CFB, Pythagoras theorem if you apply, this becomes the hypotenuse. So you will be having BC as, so BC square is equal to FB square plus FC square. The FB square means it is 4 square plus FC square is 2.5 square. So from this you get BC as square root of 4 square plus 2.5 square. Let us simplify that. 16 plus 2.5 square under root. So this will be 4.717 or 70 you can take 4.72 meters. That is the length of BC. So therefore E will be half of that length. So BE will be now half of BC midpoint. So which is 2.36 meters. So now this distance is also known. Now we will see how we can resolve and get the values of sigma f and sigma fy. So we have resolved this 16 Newton force. The 16 Newton force is making an angle of theta 1, that is 48.8 degrees with respect to x-axis, horizontal. So if you resolve this, you will get horizontal component, vertical component like this. 60 cos 48.8 degree, 60 sin 48.8 degree. Next, I have to resolve this 30 Newton, you need not resolve. This 20 Newton I have to resolve. Please be careful here. This 20 Newton is acting at right angles to this edge BC. This is 90 degrees. But this angle, you know, we have got 32 degrees. Therefore, if you resolve that, so the resolution will be like this. The arrow should move towards the arrow of the force. 20 cos 32. This is 20 sin 30. Simple, huh? That's all. So only these two forces we have to resolve. This one, this one. Remaining you need not, because this 30 Newton is vertical. You need not resolve that. 50 Newton is horizontal. You need not resolve. Now we will write sigma fx for the entire system, taking forces acting towards right positive, left negative. 50 Newton is positive, so it is plus 50. Then 60 Newton, of course, it is negative. It is acting towards left component. 60 cos 48.8 degrees. Then you have this component due to this is also negative, acting towards left, minus 20 cos 32 degrees. This moment you should not consider when you are writing this sigma fx and sigma fy. So now if you simplify this one, so we will be having this doesn't have any horizontal component. So 50 minus 60 into cos 48.8 degrees minus 20 into cos 32 degrees is equal to minus 6.48 newtons. Negative sign indicates that sigma fx is acting towards left. Now coming to sigma fy, treating forces acting upwards positive, downward negative. So here we have 50 Newton doesn't have any vertical component. 60 Newton force positive, so plus 60 sine 48.8, 60 sine 48.8, and then this 30 Newton is acting downwards, so minus 30, directly you can write without resolution. And due to this 20 Newton force, it's an upward force, therefore plus 20 sine 32 degrees, and of course due to this moment there is no contribution, so only we have to simplify this. 60 sine 48, 60 into sine 48.8 minus 30 plus 20 sine 32 plus 20 into sine 32, it comes out to be 25.74 positive. 25.74 Newton positive means it is upwards. So sigma fx is negative towards left like this. Sigma fy is positive like this. I can show like this. Sigma fy is positive, sigma fx is negative. So therefore resultant lies in the second quadrant. And this is the alpha direction of resultant. So second quadrant resultant lies. Okay. So once you know the directions of sigma fx, sigma fy, you can fix the direction of R. Now alpha magnitude of R, magnitude of resultant force, it is given by R square root of sigma fx square plus sigma fy square. It comes out to be minus 6.48 square plus 25.74 square and the root. So if you simplify that, so you will be getting 6.48 square, 26.55. 26.55 Newton, that is the magnitude of the resultant force. Direction of resultant force, that is alpha, tan inverse of modulus sigma fy by sigma fx, which is tan inverse of modulus, you have 25.74 sigma fy divided by minus 6.48. Of course, when you take modulus, it becomes positive. So I will take tan inverse of 25.74 divided by 6.48. So it comes out to be 75.87 degrees. This is the angle made by R in the second quadrant. So magnitude and direction are fixed. Now we have to find out the position. So position can be found out by considering any point of reference. So now I will take point of reference as point A. So with respect to point A, let us find out the value position of the resultant R. So for that we have to calculate sigma MA. So once you calculate sigma MA, depending on the nature, you can judge the position of the resultant. Sigma MA, clockwise positive, anti-clockwise negative. Now you should be very careful because distances should be taken correctly. Moment is given by the product of the magnitude of the force multiplied by the perpendicular distance of lever arm or moment arm from the point of concentration to the line of action of the force. Now I have taken here. So this 50 Newton force is not giving any moment about the point A because it is passing, line of action passes through A. With this 60 Newton, you have resolved into two components. Among that, the 60 cos 48.8, once again, it is passing through A. It doesn't have any moment about A, but this has moment about A. It is acting like this, therefore anti-clockwise. So minus 60 sine 48.8 degrees multiplied by multiplied by the distance. So this is a vertical force, distance is horizontal 3.5 meters. That is the moment into that. Then I will come to this point, and this force 30 Newton force. This 30 Newton force is giving the clockwise moment. So this is giving anti-clockwise, this is giving clockwise. And the distance from the point A is this horizontal distance, that is 6 meters. He has given that line of action 6 meters. Therefore, so clockwise 6 meters. So plus 30 into 6 plus 30 into 6. Then this 100 Newton meter, wherever it acts, as I already told, the effect of this coupler moment remains same. So it is given clockwise, just we have to add 100 because it is clockwise. If it is anti-clockwise, minus 100, that's all. So just add, don't multiply by the distance. So if you do 100 into 3.5, it is wrong. So wherever it is applied, the effect remains same. You need not multiply the magnitude of the external coupler moment by the distance. So plus 100. Now I will come here. This is very important. Now this is acting at E, point E. This point E is at a distance of BE is 2.36. So this distance is 2.36 meters. Now point A is here. So we need to calculate the moment of this 20 cos 32 as well as 20 sin 32 about this point A. Very, very important. This distance is 3.5 meters he has given from A to B. Now you observe that this 20 cos 22, this force is acting at this distance. Please note this. This distance I will take as y1. Because vertical distance I will take as y1. And this 20 sin 32 from A, it is acting at a distance of x1 here. Now, so x1 and y1 we have to calculate now. For calculating that, I have to take this triangle. So all of you please be careful here. I will take this triangle. So EB. Of course, I will take this point as G. Already I have taken G. So this EBG triangle I have to take. So all of you please observe here, very important step. So this is D, E, B. So this is 90 degrees. So this distance, you know, hypotenuse is 2.36 meter. And this angle. So this angle, you know that it is 58 degrees. We have calculated that. This angle is 58 degrees, therefore this angle also is 58 degrees. So now this is the thing. So I need these two distances now. So I will take cos ratio, cos 58 degree, cos 58 degree is equal to BG divided by BE. BG divided by BE. So from this BG will be BE cos 58. So that is BE is 2.36 cos 58. So let us calculate that. 2.36 into cos 58. 2.36 into cos 58 degree is 1.25. 1.25 meters. Then similarly I will take sin 58 degrees in the same triangle. Sin 58 degrees is EG. EG divided by BE. BE. So EG is equal to BE sin 58. B is once again 2.36 into sin 58 degrees. The value of this is 2.36 into sin 58 degree is 2 meters. So EG is 2 meters. Now, once you get these two distances, so this distance y1 is nothing but this EG. So y1 is EG, which is 2 meters, whereas x1 is from A to this. So that is AB plus BG. x1 is AB plus BG. So AB is 3.5 plus BG is 1.25. So it becomes 4.75 meters. So distances we should be very, very careful. So this is how we have to compute the distances. Now due to these two forces, now let us calculate the moment. Due to this force, it is anti-clockwise. See the arrow. To come to A, we have to move like this, and that should be multiplied by y1. So anti-clockwise means minus 20 cos 32 multiplied by that y1. y1 value is 2 meters. And moment due to this force is also anti-clockwise. See here. To come to A, I have to move in the anti-clockwise direction. So minus 20 sin 32. 20 sin 32 into x1. Distance is x1. x1 is 4.75. Now this is the moment sigma ma. So now if you simplify this, you will get the value of